now that we've finished going over kind of the basics of microbial metabolisms, we can start to look at what this really means for either a specific environment or, in this case, the global environmental cycles of elements. And so, as you know, microbial metabolisms, we've talked a lot about their oxidation and their reduction, and this can end up having global effects on chemical elements. And so a lot of times what we're talking about when we're talking about these chemical elements is really biogeochemical cycling, which is the pathways by which a chemical substance or element or compound moves through both biotic and abiotic components. And a lot of times with the biogeochemical cycles, there will be these sinks and reservoirs with that basically contain stocks of these chemical elements, as well as fluxes that go kind of in between them. Microbial processes will basically, they play a role in a number of these global biogeochemical cycles, especially focusing on the fluxes in between various sinks and reservoirs. And while we know they're important and we know microbes are playing a huge role in biogeochemical cycling, a lot of times in models that kind of try to predict fluctuations and changes, a lot of times microbial processes will be largely neglected simply because it's really difficult to estimate the rates of these biogeochemical fluxes, as we know so little about these environmental bacteria. So the complexes, or the cycles, are very complex, but they're mostly just shaped by the processes that we've already discussed. And so I'm just going to add two more terms because this is a little bit more commonly discussed when we're looking at it from more of the global perspective as opposed to the cellular perspective, and that's nutrient mineralization and immobilization. And all that's really referring to for mineralization is basically converting an organic compound back into the mineral form or simpler inorganic compound, such as glucose to CO2. And immobilization is the conversion of these compounds into biomass so that they're unavailable for other biogeochemical processes. So a good example of that would be fixing ammonium into organic nitrogen. So in this section, I kind of have two main goals. We have our formal learning objectives, but there are two reasons why I feel like this is such an important topic to spend some time on. One, it's good to just kind of review all of these microbial metabolism processes from this different perspective of a global biogeochemical cycle. So far we've talked about it largely as this is what the cell does to acquire energy or to build biomass, but looking at it from this kind of top-down approach can help to review it while also providing some context for why these things matter so much. Additionally, I really want you all to recognize that microorganisms, while they are tiny, single-celled, they play a major role in a number of global processes. So don't think about microbes just as they affect human health. We're about to get to the human health section. But just one more quick plug for the power of microorganisms having global impacts on the globe, on the whole planet. All right, so with that, I'll start jumping into the more content-driven videos.